The other side of the principal diagonal elements are 0. The award money for punctuality and hard work together is double one given for good behavior. For punctuality, they'll award 500. For good behavior, they'll award 2000. And for hard work, they'll award 3500 in terms of rupees. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In today's session, we are at the chapter revision of matrices and determinant, session 2. In session 1, we have discussed 1 mark and 2 mark question from the chapter matrices and determinants. So in today's session, we will be discussing the 3 marks and 6 marks question. Let us see the distribution of marks once again. So from the chapter matrices and determinants, you will be having 1 mark question, 1 2 mark question, 2 3 marks question and 1 6 marks question. In total, you will be having total marks of 15 from this chapter. Let's take up 3 marks question now. So what are the question you may expect from 3 marks question is, one of the question is this, that is proving the standard equation of matrices a square minus 4a minus 5i is equal to 0. Along with that, you might have the properties of determinants evaluation, that is evaluating the given determinant in the form of LHS and RHS and proving it using the properties of determinant. So these type of question they may ask you for 3 marks question. One is from the multiplication of matrices and the other is from the properties of determinants. So let's take few questions and solve. Here we have, if a is equal to 1, 2, 2, 2, 1, 2, 2, 2, 1, then prove that a square minus 5a minus 5i is equal to O, that is null matrix. So let us take the equation a square minus 4a minus 5i. We need to show that the resultant matrix is a null matrix. So here let's take a square. A square means multiplying the same matrix 2 times. 1, 2, 2, 2, 1, 2, 2, 2, 1. Again 1, 2, 2, 2, 1, 2, 2, 2, 1. So let's see what is a square now. So first row into first column, 1 1s are 1, 2 2s are 4, 2 2s are 4. Next first row second column, 1 2s are 2, 2 1s are 2, 2 2s are 4. Next 2 1s are 2, 2 2s are 4, 2 1s are 2. Next second row first column, 2 1s are 2, 1 2s are 2, 2 2s are 4. Second row second column, 2 2s are 4, 1 1s are 1, 2 2s are 4. Second row third column, 2 2s are 4, 1 2s are 2, 2 1s are 2. Next third row first column, 2 1s are 2, 2 2s are 4, 1 2s are 2. Third row second column, 2 2s are 4, 2 1s are 2, 1 2s are 2. Third row third column, 2 2s are 4, 2 2s are 4 plus 1 1s are 1. So what is the matrix we get here? A square as 9, 8, 8. So next we have 8, 9, 8. Next 8, 8, 9. So this is a square. Now let us consider a square minus 4a minus 5i. So a square minus 4a minus 5i. So a square is 9, 8, 8, 8, 9, 8, 8, 8, 9. Now 4 into a, that is we have to multiply 4 to 1, 2, 2, 2, 1, 2, 2, 2, 1. So let us multiply, it becomes 4, 8, 8, 8, 4, 8, 8, 8, 4 minus 5 into I means multiplying 5 to identity matrix, that is 1 0 0 0 1 0 0 0 1. So multiplying 5 we get 5 0 0 0 5 0 0 0 5. Now let us evaluate it. 9 minus 4 is 5, 5 minus 5 is 0. 8 minus 8 minus 0, 0. 8 minus 8 minus 0, 0. Again 8 minus 8 minus 8, 0. 9 minus 4 minus 5, 0. 8 minus 8 minus 8, 0. 8 minus 8 minus 0 is again 0. 8 minus 8 minus 0, 0. 9 minus 4 minus 5 is 0. So therefore, this is equal to the null matrix O, because the result we got it is a null matrix. Hence, we have proved it. If A is equal to 2, minus 1, 1, 4 and B is equal to minus 3, 2, 1, 4, show that AB whole dash is equal to B dash A dash. That is, we are going to prove the one of the property of a transpose matrix. So first, let's check AB into B dash. So first find out AB. First row, first column. So we have minus 6 plus 1. Next 4 minus 4. Next we have minus 3 minus 4. Next we have 2, 16. So AB we will get it as minus 5, 0, minus 7, 8. Let's take the transpose, that is AB whole dash. AB whole dash is minus 5, minus 7, 0, 8. Let me take this as equation 1. Now let's multiply B dash into A dash. Let's take B dash into A dash. Write B dash. B dash is minus 3, minus 1, 2, 4. A dash is 2, 1, minus 1, 4. Now let's multiply. Minus 3 2s are 6, minus 6 plus 1. Next we have minus 3 minus 4. Next we have 4 minus 4. Next we have 2 plus 16. So B dash A dash is equal to minus 5, minus 7, 0, 18. So take this as equation 2. So from equation 1 and 2, we can conclude that AB whole dash is B dash into A dash. Next question. Prove that 1 A plus B, A square plus B square, 1 B plus C, B square plus C square, 1 C plus A, C square plus A square, A minus B, B minus A, C minus A. So this was a question asked in March 2016. Now let us consider the LHS. So LHS is given 1, 1, 1, A plus B, B plus C, C plus A square plus B square plus C square plus A square. Now, using elementary row or column operation, we can evaluate the determinants. Now, so that I'll take R2 dash as R2 minus R1 and R3 dash as R3 minus R1. So, let's see what we will get. So, this is equal to, first one is same, 1 A plus B, A square plus B square. So 1 minus 1 is 0. B plus C minus A minus B becomes C minus A. And this becomes C square minus A square. Next we have again 1 minus 1, 0. We have C minus B. And here it is C square minus B square. Now in the second row we have C minus A as a common factor. In the third row we have C minus B as a common factor. Let us take it out. So C minus A, C minus B. If you take it, you have 1 A plus B, A square plus B square. Here it is 0, 1 C plus A, because C square minus A square means C minus A, C plus A. Similarly, here 0, 1 C plus B. Let us evaluate this determinant C minus A into C minus B. I am evaluating with respect to column. So, plus minus plus, we have 1 into C plus B minus C minus A, and here plus 0 into any factor 0, plus 0 into any factor 0. So, we will write here plus 0 plus 0. So, clearly you can see here minus C plus C cancels, we have B minus A. So, we have now C minus A, C minus B and B minus A. Let me take minus common factor from these two, then it becomes A minus B, B minus C and C minus A, that is equal to the RHS given. That is A minus B, B minus C, C minus A. Hence, we have proved it. Next question. Solve 2 plus x, 3 minus 4, 2, 3 plus x minus 4, 2 plus 3 minus 4 plus x. So, this is equal to 0. So, this is also one of the application of determinant here. They have given the determinant value is equal to 0, so that we need to find the value of x. So, for this, what I will do, let me take column 1 as column 1 plus column 2 plus column 3. That is, add all the columns. So, what you will get in the first term, you will get it as x plus 1, x plus 1, x plus 1. So, you have 3, 3 plus x, 3, minus 4, minus 4, minus 4 plus x. That is equal to 0. Now, I will take R2 dash as R2 minus R1 and R3 dash as R3 minus R1. So, then it becomes x plus 1, 3 minus 4. Next, 0, 3 plus x minus 3 is x, minus 4 becomes 0. Next is again 0, 3 minus 3 0. Next, minus 4 plus x, again it becomes x. So, this is equal to 0. Now, expand the determinant. So, here we can see this is the principal diagonal. The other side of the principal diagonal elements are 0. Hence, by using the property of determinants, the value is equal to the product of the principal diagonal element. What are the principal diagonal elements we have? X plus 1, x into x. So, the value of the determinant is equal to the product of the principal diagonal elements. That is equal to 0. So, now we have here x plus 1 is equal to 0. X into x is x square is equal to 0. So, this implies x is equal to minus 1 or x is equal to 0. So, this is the value of x. Again, this comes under 3 marks question category. So, one more property that comes under 3 marks is proving A into adjoint A into A, determinant A, I. So, here we have A here. So, let's take adjoint A. To find adjoint A, we need to interchange the principal diagonal elements and write negatives of the other diagonal. So, this is adjoint A. Now, let's check A into adjoint A. What happens for A into adjoint A? Minus 1, 2, 3, 4 is equal to 4 minus 2 minus 3 minus 1. Now, let's see it. Minus 1, 4 minus 4, 2 minus 3 minus 6. Minus 1 into minus 2 plus 2, 2 into minus 1 minus 2. 3 into 4 is 12 minus 12. Next, 3 into minus 2 is minus 6. 4 into minus 1 is minus 4. So, we get A into adjoint A is equal to minus 10, 0, 0, minus 10. Now, let's check it for adjoint A into A. So, adjoint A into A is 4 minus 2 minus 3 minus 1 into minus 1, 2, 3, 4. Let's multiply. 4 in minus 4 minus 6. Next we have 8 minus 8. Next we have 3 minus 3. Next we have minus 6 minus 4. So that is equal to adjoint A into A, which is minus 10, 0, 0, minus 10. Now let's check determinant A into I. Determinant A is minus 1 into 4 is 4 minus 3 2s are 6. So minus 4 it is. Into I is, since we have taken square matrix, it is 1 0 0 1. So this is minus 10. Minus 10 into 1 0 0 1 is minus 10 0 0 minus 10. So here let me take this as equation 1. Let me take this as equation 2 and let me take this as equation 3. Observe all the matrices 1, 2 and 3. So they are one and the same. So therefore what we can conclude? A into adjoint A is equal to adjoint A into A is equal to determinant A into I. This can also be verified for 3 cross 3 matrices also. Show that 1 plus A, B, C, A 1 plus B, C, A, B 1 plus C is equal to 1 plus A plus B plus C. So which was asked in March 2019 and March 2020 annual examination. So let me consider the LHS here. So LHS is 1 plus A, B, C, A 1 plus B, C, A, B 1 plus C. So here I will take column 1 as column 1 plus column 2 plus column 3. When you add all the columns, you will get the first column as 1 plus A plus B plus C, 1 plus A plus B plus C, 1 plus A plus B plus C. The other column is B, 1 plus B, B, C, C, 1 plus C. So take 1 plus A plus B plus C from the column 1. 1 plus A plus B plus C, if you take, the first column will be 1, 1, 1. B, 1 plus B, B, C, C, 1 plus C. Next I will take row 2 as R2 minus R1 and R3 as R3 minus R1. So we will get 1 plus A plus B plus C. First column becomes 1, 0, 0. Second column is 1 plus B minus B is 1, B minus B is 0. So it becomes B, 1, 0. Next, third column is C minus C, 0. 1 plus C minus C is 1. So it becomes C, 0, 1. Clearly you can see this is a principal diagonal, and under the principal diagonal all the elements are 0. So using the properties of determinant, what I can write here? The value of the determinant is the product of the principal diagonal element, that is 1 into 1 into 1, which is 1 again. 1 into the factor given as 1 plus A plus B plus C, that is the RHS given. Hence we have proved it. So these are the question you may expect for 3 marks question. Now let us move for 6 marks question. All 6 marks question mainly will be for the evaluation of simultaneous linear equation by matrix method. Either they will give you any statement problem to solve, or they will give you direct linear equation to solve it by matrix method. So here I have taken an example of a school wants to award its students for the values of punctuality, good behavior, hard work with a total cash award of rupees 6,000. 3 times the awards money for hard work added to that given to punctuality amount to 11,000. The award money for punctuality and hard work together is double the one given for good behavior. Represent the above situation algebraically and also find the award money for each value using matrix method. So this was asked in July 2015, March 2017 and March 2018. Now let's see it. So for punctuality, good behavior and hard work, the total cash award was 6,000. So that's why it is X plus Y plus Z is equal to 6,000. Next, 3 times the awards for hard work added to the punctuality. We have taken X for punctuality, Y for good behavior, Z for hard work. 3 times hard work is added to the punctuality, which will gives you 11,000. Next, they have given the award money for punctuality and hard work together is double one given for good behavior. So that is equal to double the good behavior. So punctuality we have taken as X, hard work we have taken as Z. So therefore X plus Z is equal to 2Y. 2 times the good behavior they have given. Now here we will replace the equations. So I'll rewrite the equation as x plus y plus z is equal to 6000. Next, I don't have any y terms, so it is 0. And here I have 3z, that is equal to 11,000. Next, here I have x, 2y I will shift here, it becomes minus 2y plus z is equal to 0. Now, let us write this in terms of matrices. The coefficients of x, y, z I can write it as A, and the constant I can write it as B. The variables I can write it as x. So, let us take matrix A is equal to 1, 1, 1, 1, 0, 3, 1, minus 2, 1. And x is a matrix of x, y, z, and B is 6,000, 11,000, 0. Now let's find the determinant value. So why we need to find out the determinant value? To verify whether A inverse exists or not, because we are doing by matrix method. To find the coefficients of x, y, z, we need A inverse. So let's find the determinant value. So for 1, it is 0, minus of minus 6 is plus 6. Next we have minus 1. So for minus 1, it is 1 minus 1 again. Next for the last column, plus 1. So for 1, it is minus 2, minus 0. So solving this, we have 6 plus 0 minus 2. So determinant A is equal to 4, which is not equal to 0. Therefore, what we can conclude? A inverse exists. Once we got A inverse exists, we need to find out adjoint of the given matrix. After writing A, X, B, we need to calculate the value of the determinant. So why we need to find out determinant value? To show that A inverse exists. So now let's write the determinant A. So for 1, it is 0 plus 6. And for second one, minus 1, it is 1 minus 3. And for the last one, it is minus 2 minus 0. So here the value is 6. Minus 2 minus 1 is plus 2 minus 2. So the determinant A value is equal to 6, which is not equal to 0. So therefore, A inverse exists. So once you found A inverse exists, the next step is we need to find out adjoint A. So what is adjoint A? Adjoint A is a transpose of a cofactor matrix. How will you write the cofactors? With the sign inside and taking the minors of each element. So for the first 3, we have already written 0 plus 6, 1 minus 3, minus 2 minus 0. Next we will look it for 1. So delete the row, delete the column. 1 minus of minus 2 becomes plus 2. Next for 0, it is 1 minus 1. Next for 3, delete the row, delete the column. So minus 2 minus 1. Next we take for the third row first element. So it is 3 minus 0. Next we will take for minus 2. So for minus 2, delete the column, delete the row. So it is 1 3 is a 3 minus 1. Next for the last element, delete the row, delete the column. So we get 0 minus 1. So these are the minus. Now to find the cofactor, substitute sign here. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Take the transpose to find the adjoint. So therefore, adjoint A is equal to, now we have 6, 1 minus 3 minus 2 plus 2. Next minus 2, here minus 3, 0 plus 3, 3 minus 0, 3, 3 minus 1 minus 2, minus 1. Take the transpose. So what is the transpose? 6, 2, minus 2, minus 3, 0, 3, 3, minus 2, minus 1. So this is the transpose of a matrix That is the adjoint A. So once you got adjoint A, the next step is we need to find out A inverse. So that is, we have x is equal to A inverse B. So we get x is equal to A inverse is nothing but adjoint of A divided by determinant A into B. So let's keep adjoint A outside. So 1 by 6. Let's write adjoint A. What is adjoint A? We have 6 minus 3, 3. Next, 2, 0 minus 2. Next, minus 2, 3 minus 1. And B we have 6,000, 11,000 and 0. Now let us take x, 1 by x outside. Let's solve this. So we have 6, 6 are 36,000 minus 33,000 plus 0. Next, 12,000 minus 0 plus 0. Again plus 0. Next we have minus 12,000 plus 33,000 plus 0. So we get x is equal as x, y, z is equal to. So we have here 36,000 minus 33,000, 3,000. 3,000 divided by 6, we will get it as 500. Next we have 12,000 divided by 6, which is 2,000. Next we have 33,000 minus 12, which is 21,000 divided by 6, which becomes 3,500. So therefore, from this we got x is equal to rupees 500, y is equal to rupees 2,000 and z is equal to rupees 3,500. So that is, for punctuality they'll award 500, for good behavior they'll award 2,000 and for hard work they'll award 3,500 in terms of rupees. Other type, they may give you directly the linear equations to solve and find the values of x, y, z. So let's look at the question. Solve by matrix method. 3x plus y plus 2z is equal to 3. 2x minus 3y minus z is equal to minus 3. X plus 2y plus z is equal to 4. So this was asked in July 2016. So in the previous question, we have only framed simultaneous linear equation and solved the values for x and y and z. Here they have given the linear equation. We are supposed to solve and find the values of x, y, z. Let's look at it. Let's write the matrix. We have 3, 1, 2. 2 minus 3 minus 1. 1, 2, 1. So this is matrix A. Next matrix X is x, y, z. Matrix B is equal to 3 minus 3, 4. So let's find the determinant A. So determinant A is 3 into minus 3 minus of minus 2 plus 2. Minus 1. So we have 2 minus of minus 1 plus 1. Next plus 2. So we have 2 2s are 4 minus of minus 3 plus 3. So here we have minus 3 plus 2 minus 1. Minus 1 into 3 minus 3. 2 plus 1 3 minus 3 again. 4 plus 3 7. 7 2s are 14. So determinant A is equal to, we get 8, which is not equal to 0. So once determinant A is not equal to 0, that implies A inverse exists. So therefore A inverse exists. So once you find A inverse exists, the very next step is we need to find out adjoint. So that is the transpose of a cofactor matrix. So let us write the minus here first. Minus 3 plus 2. For the first 3 terms we have already got 2 plus 1 and 4 plus 3. Next, for the next 2 here, delete the column, delete the row. 1, 1s are 1 minus 4. Next, for minus 3 it is 3 minus 2. Next for minus 1, it is 3 2s are 6, minus 1 1s are 1. Next for 1, it is minus 1 plus 6. For 2, it is minus 3 minus 4. Next, for the last one, it is minus 9 minus 2. Take the transpose, substitute the sign, plus minus plus, minus plus minus, plus minus plus. So, adjoint A is equal to minus 3 plus 2, minus 1, minus 3, 7. Next, 3, 1, minus 5. Next, 5, 7, 11, minus 11. Take the transpose of it. So, therefore, adjoint A is equal to minus 1, minus 3, 7, 3, 1, minus 5, 5, 7, minus 11. So, now let's take x. We have x is equal to A inverse B. X is equal to adjoint A divided by determinant A into B. So, let's take determinant A out. Write the adjoint A. Minus 1, 3, 5. Minus 3, 1, 7. 7 minus 5, minus 11. And matrix B is 3 minus 3, 4. 3 minus 3, 4. So, now x is equal to 1 by 8. Let us multiply. So, minus 1 into 3, minus 3, minus 9, 20. Next we have minus 9, minus 3, 28. Next we have 21 plus 15 minus 44. So, here let's take x. X in the form of x, y, z. Now, add the value divided by 8. So, it is minus 12 plus 20, 8. 8 by 8 is 1. Next, we have minus 12 plus 28. It is 16. 16 by 8 is 2. Next, we have minus 36 minus 44, which is minus 8. Minus 8 by 8 is minus 1. So, therefore, the value of x is 1, y is 2, and z is equal to minus 1. So, this is how we will find the solutions for x, y, z using matrix method. So, these are the very important concepts which you may expect from the question paper point of view from the chapter Matrices and Determinants. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.